Hello once again. In our previous video, we talked about the derivative of sine inverse of x or sine inverse of u or sine inverse of any function at all. We've discussed that. So with this, we are going to take that of the cos inverse of u. How do we then prove this? We said derivative of cos inverse of u equals minus u prime divided by square root of 1 minus u squared. So with this, to start, still we make y to be our cos inverse of u. So with this, we can rewrite it also as cos y equals u. Still using our right angle triangle. Since y is here as cos y, meaning y is an angle. So our acute angle is now y over here. So its opposite is here, adjacent is here, hypotenuse is here. But we know cos y will be adjacent over hypotenuse. So meaning that u, we can rewrite this u as u over 1. Good. So since cos is adjacent over hypotenuse, meaning the adjacent will now be u and the hypotenuse will be 1. So with Pythagoras theorem once again, here we'll get it to be square root of 1 minus u squared by just using 1 squared equals u squared plus any variable you can put here, maybe t squared. So make t the subject and you get 1 minus u squared. Exactly. So with this, I'm going back to my equation here, which is cos y equals u. I can differentiate it also using implicit differentiation, use just with x as a variable of integration, differentiation, sorry. So we differentiate this, you get differentiate cos, you get minus sine of y, but I'm differentiating with respect to x. So it will then be dy over dx multiplying it equals, then I'll do same here. So I'll differentiate here, I'll get du over dx. Good. So with the idea here, we are still trying to make dy over dx the subject because y is now representing our cos inverse of u, which you want to find the derivative of. So it will then be dy over dx equals minus du over dx, all divided by sine of x. So I brought the negative here already. So with that, du over dx can be represented by just u prime. Okay, sorry, here is sine y. Du over dx can be represented by just u prime divided by. Now let's go. Sine y. We said these are y. Sine y is opposite over hypotenuse. Opposite is now what? 1 root of 1 minus u squared. And the hypotenuse is now 1. So with this, we get square root of 1 minus u squared, all divided by 1, which we can just forget since the number divided by 1 is the same number. So in this, you can rewrite it as minus u prime, all divided by root of 1 minus u squared. So you can see we have proved it simply. So that's why they said what the derivative of cos inverse of u will just be u prime all divided by square root of 1 minus u squared. So we are applying this in your differentiation. So let's take some examples on this. Okay, let's assume we have to find the derivative of sine inverse of x power 4. So to do this, we still have to make what? The one inside the bracket. You can try it at home, fine, before we start the solution. So we make x power 4 u. So let u equals x to the power 4. So with this, I will find my du dx. So du over dx, which is the same as u prime. We can just find the derivative of this, which will give us 4x power 3. So with this 4x power 3, I'll just substitute it into this equation, which is said u prime over square root of 1 minus u squared. So that will be dx cos inverse of u will now be equal to cos inverse of x power 4 will now be equal to u prime minus u prime, but u prime is now 4x to the power 3. So we substitute it here. 4x to the power 3 all divided by square root of 1 minus u square. So square root of 1 minus, now our u is what? From here we get our u to be x power 4. So put x power 4 all squared. Good. So with this, we simplify. Minus 4x power 3 all divided by square root of 1 minus. So here the square is multiply the 4 there to give us x power 8. So this is just how to apply the concepts of inverse derivative of inverse trig functions to solve questions. Thank you very much.